Hello, everyone. This video is to show you how to look at the relationship between two different variables. So the variables I'm going to use from my data set are batter's average age and home runs hit and allowed. So what we're going to look at is we're going to put that, we're going to move this box and whisker plot over here, and we're just going to come down here and we're going to use what's called sample covariance and sample correlation. So for covariance, we're going to just type in COV, and we see these covariances P and S. We're going to use S for sample. And now it wants my array 1 and array 2. I'm going to zoom in a little bit so you guys can see this a little bit better, I think. And then we're going to go find our data set again. So we're going to use batter's average age. So E3 down through E32 is your first array. And then type in a comma. And we want to see if that has any, has any relationship with home runs. So then we just start highlighting N3 down through N32. And we close our parentheses and hit enter. And what do we have? We have a negative 1.3. And again, we have our error telling us that we don't have all of the variables. So this is our sample covariance. So what this is telling us is that if there is a relationship there, it's going to be a negative relationship. So that as one goes up, the other is going to go down. And if you think about it, as your age increases, do you expect more home runs? Maybe not. So as your age goes up, maybe the number of home runs you hit goes down. That's what this sample covariance tells us, is that there's a negative relationship there. If you get a positive, obviously, that's going to tell you there's a positive relationship and they move together. If you get something near 0, it's going to tell you that there's really not much of a relationship there at all. So now we're going to look at the sample correlation. This is going to tell us the strength of that relationship. So we're going to put correlation. If I can spell correlation right, there's only one L. There we go. And to find that, we type in core, C-O-R-R, equals, and it's correl, C-O-R-R-E-L, and then again, we need our arrays. So we are looking at E3 through E32, and I believe the other one was home runs N, so comma, N3 through N32, and we hit enter. And that gives us a sample correlation very close to 0. Again, what this is telling us, so the correlation is telling us the strength. Your correlation is going to go from -1 to +1. And if it's very close to the ones on either side, it means you have a really strong relationship. So if you put your points, if you plotted them on a graph, you'd have a very strong either linear line, negative linear line, or positive linear line. Obviously, these are negative, so this would tell us that we'd have a negative linear line on our graph. However, since it's close to 0, very close to 0, this is telling us that the strength of that relationship is not very good. So you're going to have dots kind of scattered all over the place with a little bit of a negative trend, but they're still going to be pretty scattered and there's not a very strong relationship. So that's how you find sample covariance and correlation.